Any questions on chapter 8? So 8 was a little shorter. 7 was a longish one. 8 was a little shorter. 9 is not too bad, and then 10 will be pretty quick. Flame failure detectors. We're going to look at things called scanners, and we're going to look at some scanners that detect ultraviolet radiation, types of radiation. When you burn things or you have a flame, you're going to create some UV, and that's why we can see a flame. And also infrared, this is the heat energy created in the flame. So we're going to scan that with some devices. Some other devices that work a little differently, thermopiles and thermocouples and flame rods. These scanners actually are photocells. So photoelectric cell or rectifying photocells. There is something mentioned called the thermal stack. This is very old school technology. And we'll look at how to test these devices and talk about why we need them. Why do we need them? Fuel will enter the furnace. We satisfy all the conditions for all the controls. The valves will open. The fuel will flow if we open or line up all the correct valves. It's going to be vaporized or atomized fuel of some kind. There will be combustion air, and we need to make sure that it gets burning. Okay? If it is not burning or goes out or fails to ignite, the fuel must be shut off immediately. Okay? Because if we keep pumping fuel into a furnace, 178, and it mixes with some air and something in there is hot from before, it's possible that we could have a different kind of boiler failure or disaster called a furnace explosion. Okay? So we want to make sure we have some kind of flame failure detection. Fuel should be shut off immediately if the pilot flame or main burner flame fails to ignite. The function of these devices, there's quite a few names, quite a few types. We'll go through them in a chapter, is simply to shut off the fuel to the burner when it doesn't ignite or is stopped during operation. Okay? Boiler flame failure detectors. Fuel should be shut off if pilot flame or main burner fails to ignite. Another way to say it, the function of a flame failure device is to shut off the fuel to the burner if a flame fails. So different types, thermocouples and thermopiles are devices that they're just really simple, they're really basic. They create a milliamp electric signal when they're hot. If there's enough fire to heat this device up and create enough of an electric signal, that signal will open a solenoid valve and allow us to keep the gas flow running. For some reason I'm getting a little cold in here. How's everybody doing? All good, happy. Nobody's gone away yet. Can't tell if you're sleeping, but we'll figure it out. Another device is a simple device, a basic device called a flame rod. Something to remember about a flame rod is a flame. It contains ionized gases, and we're going to learn about what will cause or allow electricity to flow, and an ionized gas is conductive, which means that it can create a circuit. So the switch in a flame rod system is the flame itself. As long as the flame exists, electricity is conducted and the burner device can be turned on. Gas valve device can be turned on and keep the gas coming. And if the flame does extinguish or blow out, the current is stopped and then the gas flow is shut off. Scanners are a little bit more sophisticated. They detect radiation or radiant energy from the flame. They need to see the flame. They don't have to touch the flame. These other devices, actually, flame rods and thermocouples and thermopiles, need to be in the flame. They need to touch the flame. Scanner or photoelectric cell only needs to see it, but it's important that it see the flame. If that view is blocked off, the device will signal a flame out or flame extinguishment, and then we'll shut off the gas. And they work on infrared or ultraviolet radiation. So the basic thermocouple is just a couple of wires connected to a load. This can be your solenoid or your gas valve in a small system. It has dissimilar wires welded together, and that joint or junction is in the flame, creates a voltage and supplies power to keep the gas valve on. When heated, an electric signal is generated, causing a small current, and we use that to turn on the gas valve. So here's the thermocouple, and this particular one is right in the flame of the pilot. Pilot is a small burner or a small flame that's there to ignite our bigger flame. Once the thermocouple is heated up by the pilot flame, then that allows the main gas valve to open and energize an electromagnet or solenoid to keep that switch closed to open up a gas valve. This thermocouple controls something called a pilot stat or a gas valve. As long as we have a flame on the thermocouple, it will open the gas valve and allow us to light the main burner. Sometimes we put multiple hot junctions together. So this is multiple 1, 2, 3, 4, 5, 6, 7 thermocouples in series. So they're connected one to another. And this is simply, it's called a thermopile. Multiple thermocouples to create a higher voltage to control the gas valve system. We call that a thermopile. Another simple basic type device is a flame rod. If you've ever done maintenance on your furnace, you might have seen a device like this. This is the flame rod, and the flame rod is in the flame. And as long as there's fire in the burner, there will be an electrical circuit through a relay panel, and that will keep the gas valve open. The flame becomes part of the circuit. This really only works with gas burners. This device will shut off the gas within 4 seconds, or should shut off the gas within 4 seconds should the flame stop. And another name for this is flame rectification. Flame rod is called flame rectification. And you'll probably need to wipe these guys clean once in a while if you have one. Flame rod, remember, it means the flame becomes part of the circuit. The electric circuit is closed when there's a flame on. and supplies power to keep the gas valve on. Okay. Scanners. If you have a boiler at work and you've seen a box like this on the end of it, perhaps you've seen, so this one is called FireEye. This one was popular when we were going from really old technology and spending hours and hours and hours at the boilers in the utility plant, mucking with the scanners to keep things running. The old scanners look like this. And we went to this, it's called a purple peeper. Looks like Honeywell bought them out too, and now they're 7006 flame detectors, but we used to call them the purple peepers. Might be called a scanner, might be called flame detection device, might be called a FireEye. These are brand names that people name the device by the brand name. Thing about devices called scanners is they react to infrared or ultraviolet radiation. They need to shut off gas within 4 seconds, and we'll talk about that on a little later. They're mounted to scan or see the flame. They might be called infrared scanners. They might be called ultraviolet scanners. Modern technology has combinations, infrared, ultraviolet, for different reasons. And rectifying the photocell is another type. Lead sulfide, so the old school scanners on 9-6, infrared scanner. Flame signal voltage is amplified and holds a relay open. Flame relay controls the power to the gas valve. So this device does not need, you don't want to have the flame in close proximity. The flame is over here, and the device is going to look at the flame and sense the radiation. So radiation will go to the device. If these guys get too hot, there's going to be problems because there's electronic circuits in them. So they're away from the flame. So here's our scanner back here. Scanners use photoelectric cells, require a line of sight. So you'll see the line. The scanner is mounted at the end of a long tube. The tube is pointed at the center of the flame. A single scanner can monitor a pilot burner and a main burner. So if there's some fire here, if the pilot is lit, it's going to allow us to open gas to the main burner and turn that on. And if there's no flame here, no pilot, no main flame, this would remain shut based on the signal from the scanner. Scanners use photoelectric cells, require the line of sight. Important to remember this, this tube. Generally, this device will have some kind of a window on it. Okay. So the window should be clean, and if you remove this device, you should be able to look straight down the tube and see the area where the flame is. If you've removed it, you're going to shut down the gas. You won't see a flame, but you should be pointed at the flame. And the devices have meters on them that allow you to make adjustments to that angle to get the strongest position to aim them at the flame. The old school rectifying photocells were called CAD cells, figure 10 on 9-7. Cathode exposed to light. So these ones just saw a flame, they saw visible light. Sometimes back in the day mounted inside of a burner housing. Not the best way to be able to test it and adjust it, but That's where they had them. So testing of these devices. The function is to shut off the fuel to the burner if the flame fails. Thermocouple produces milliamp electric signal. Thermocouples in series is called a thermopile. It's just creating a higher voltage because there's more thermocouples. Flame rod forms an electric circuit through the rod and connected to a relay to supply power or not to the gas valve. Flame protection testing, simulated flame failure. Always follow the instructions that come from the manufacturer. Test the main burner protection. One method is just simply shut the gas. Turn off the gas, fire goes out, device will trip the system. Okay, that's one method. There's a couple other methods we'll look at. Flame rod should be checked for buildup, cleaned often. Flame rod should cause main gas to close within 4 seconds. Flame rod devices and scanners should shut off the main fuel valve within 4 seconds. Okay, so the flame rod system, the flame conducts electricity. If we have a complete circuit, the relay will send power to the gas valve and turn on the gas. Okay. Flame rods and flame scanners should shut off the main fuel valve within 4 seconds. Automatic pilot valve must close in 10 seconds. So if you look at page 9 starting on 9-8, describe testing of boiler flame safety devices. So there's testing flame safeguard devices. It says pilot and main gas should be shut off in the time recommended by the manufacturer. They talk about a thermocouple or thermopile system, time recommended by the manufacturer. And I'd highlight these things that I'm mentioning as you go through those pages. Oil burner has a thermal type stack switch. Time taken to shut off should be recommended by the manufacturer. And then the important ones start on page 9-9. Gas burner with electronic flame rod. Number 2 says close the gas, note the time it takes. This should take 4 seconds or less. So I'd highlight the 4 seconds. I've written in big letters beside, highlighted flame rod, and then I've written 4 seconds. The next paragraph says gas burner with flame rod. Step number 1, close the main gas valve. Note the time it takes for the gas valve to close, should take no longer than 4 seconds. Next one says gas burner with flame scanner. Method 2 is A, remove scanner from the sighting tube. So if you have a scanner, you simply take it off the boiler, cover it up. Note the time it takes for the gas valve to close. It's going to be 4 seconds. And then the next one, photoelectric cell, is also 4 seconds. When you flip the page, it says checking pilot flame failure protection. Number 2 says start the programming control. You've already shut the gas manual valves to pilot and main burner. Pilot valve will close in about 10 seconds. And somewhere there's one more. No, that's the only time that it's 10 seconds when we're talking about pilot flame failure detection. So generally 4 seconds, and then in one instance when it's a pilot flame, it can close. A pilot flame is a small flame, a small amount of gas, so it can be a longer time. We need to close it as quickly as possible, but times like 4 seconds are realistic and reasonable. Right? So flame rod devices and scanners should shut off the main fuel valve. Most devices are allowed 4 seconds, but if it's a pilot scanner, pilot flame scanner, it can take 10 seconds to close. Okay, flame scanners have photoelectric cells and need a clear line of sight to see the flame. And this is to prevent furnace explosions. If fuel should collect, unburnt fuel collects in a boiler, fills up the boiler, fills up some gas passes. There could be an extremely large volume of fuel seeping into a furnace if these devices don't work properly. Boiler might have just been shut down 10 minutes ago. Some things can be very hot in there, hot enough to ignite, or fooling around with controls and interlocks. Somebody's inside of a panel with a screwdriver pushing on relays, trying to get things to run in a hurry. Ignition occurs when those passages are full of gas. That could be a furnace explosion, and that's not the same as a boiler explosion. It's an explosion in the boiler furnace, but it's explosion of fuel in the furnace, as opposed to a pressure part explosion. Okay. Section 6, rules for care and operation of heating. Boilers describes recommended procedures for testing safeguard devices. So if it's not construction, took my little list away. If it's not construction, it's operation. Rules of care and operation. Heating boilers is 4 and 6. Construction is 6. Construction is 4 and operation is 6. A little review. Chapter 9, flame failure devices. Flame failure devices do not shut down the flame. Must be installed on every boiler, not just high pressure. Do not control the pressure, and will shut off the fuel to the burner. If fuel fails to ignite, we shut it off immediately to prevent furnace explosions. Function of a flame failure device, another way to say it, is shut off the fuel if the burner flame fails. Okay, does not shut off feed water, does not shut off on temperature, and does not have anything to do with pressure. Thermocouple, which one is true? Okay. Don't get tired yet. We have one more chapter. Thermocouples connected in series. This is called a thermopile. It generates a higher voltage. It's the same thing. It has hot junctions, that just multiple junctions connected together in series. Flame rod forms an electric circuit with the rod and the flame and a burner. Okay. Scanners send a signal to something called a flame relay. Not a thermal switch, not a transducer, not a rectifier. A scanner is not a flame rod. Flame rod can be called flame rectification, but a scanner is not a flame rod. Flame relay controls power to, not a rectifier, not a circuit breaker, not a thermal switch, but the main gas valve. 2 of these are true. Which ones? Yellow. Okay. Clear line of sight and require a photoelectric cell. Scanners do not see the temperature or measure the temperature, and they do not produce a steady voltage signal. A bigger flame is a bigger voltage. A smaller flame is a lower voltage. No flame is zero voltage, shuts things down. Test flame failure devices according to manufacturer's instructions, and you'll usually do that by simulating a flame failure. Two ways to do that: actually fail the flame, shut off the gas. Another way, if it's a scanner, you can remove it from the flame. Okay. Flame rods should shut off the fuel within 4 seconds. Close the main fuel valve. Should close the main fuel valve within 4 seconds. 2 of these. Which 2? Okay, scanner and flame rod. If it's a thermocouple, it's probably a pilot, and then a pilot gives you 10 seconds. Okay. Within 10 seconds, thermocouple. Checking burner flame protection. Another way is close the main burner fuel shut off. Okay. Nothing to do with pressure. Chief is not going to be talked to every time. If you're checking the flame protection, the fuel solenoid will be de-energized. Simplest maintenance for scanners is check the sight tube and clean the lens. How many seconds for the main gas valve to close when a scanner is used?
4 seconds.
4 seconds. Thermocouple has dissimilar wires welded together, forming a what? Measuring junction. Thermocouple is exposed to heat. What is generated?
Voltage.
Voltage. Pilot flame fails, thermocouple voltage drops to prevent fuel to probably both of these. Pilot valve to close in the event of a loss of flame. So if it says pilot, it's going to be 10 seconds. Flame rod is called flame rectification. Infrared or IR scanner contains what kind of cell?
Lead.
Lead sulfide. Okay. Receives a signal from a boiler detector, flame failure detector, to control the power supply to the gas valve. The answer is in the picture. Okay, there's another brand there, Sunflame. Okay, I'm getting tired. Chapter 10 is boiler programming controls. Boiler programming controls, so just some other kinds of devices and how they all tie together. Some startup sequence and shutdown sequence. And there's quite a few pages of, actually just a couple pages of bar graphs, but we have a bunch of slides of bar graphs. So we'll show you a couple of those, and then we'll review and ask a few questions, and then that'll be it for this evening. So earlier I kind of got ahead of myself. I was talking about doing more than the 4 chapters tonight. That applies to next week. Week number 4, we'll be compressing our chapters into Tuesday. So on Thursday, we can start the review that will finish in week 5 on Tuesday, and then take the exam. So I transported myself ahead in the future because today I was working on that review for you, working ahead. So, okay, if everybody's good, we'll do this chapter 10 and call it a night. All right. Big sigh. Was that a big sigh? I actually have a headache. I don't get headaches very often. Considering the amount of painkiller I take for my hip, I should never have a headache. Basic boiler combustion control. So we've talked about some of the principles here. We'll just look at more details now. On-off control. If we have a small package boiler, that's going to be the mode of control. Simply on-off. Fire it up. Get to a set pressure. Shut off the burner. Pressure drops down. Controls will cycle it on and off to keep pressure within a range. If it's a steam boiler, it'll be pressure. If it's a hot water boiler, it will be temperature. Temperature control using one of those Controlling temperature on a hot water boiler is done with a thermal element. Most often we call it an aquastat. Bob was going to say that, right?
I couldn't get to the mouse in time.
Yeah, I was talking, and then I saw your mute go off. Boiler controls provide sequencing of combustion events. So I'm just going to jump ahead. We've looked at, I hope I'm in the right. I can see it in the textbook. Just let me jump ahead. So we talk about operating controls. We talk about combustion air controls. Here's a list of things that are going to be in a boiler in the control system right here. So starting switch, power on. Operating control, pressure is set to shut down operating control at 15 psi. So operating control. This is not a boiler that's under constant supervision, so we also have a high limit control. Something higher than number 2, so higher than operating limit, but lower than safety valve set pressure. There's also a low gas pressure fuel cutoff, low water fuel cutoff, a second low water fuel cutoff. I'm not sure why we don't see a high fuel pressure cutoff here, but that would be on the list, should be on this list. And if you look at the list and then glance over here, you'll see a bunch of open switches. So the open switch is signified by a little line where it's not connecting the other line. So unless all 6 limit switches are closed, we won't have any power to this system. Okay, so main power is coming in from the main breaker. First, we have to close this. Then we energize these buses. And if we don't energize all of these switches, the system doesn't run. So this is why we call these interlocks. Okay, if all the limit and operating switches are not made or closed, the system is just not going to run. Okay, once we have all these things ready to go, and there will be a sequence. Also, we need to have the air pressure switch here made. And power on, master relay energized, burner switch turned on. Then we can get some things happening down here. And the control system, basic control system on a burner, basically prevents it from running unless we have all these things satisfied. And then it puts things through a sequence. So these are different relays and switches that will turn on and turn off as we supply gas to the pilot burner. Once we supply gas to the pilot burner, we start an igniter, and then that will create a flame. The scanner will turn on a relay that will allow the main gas burner valve to open, and then we can put main gas in and we can light things up. And all these things have to stay in their proper position, which is turned on, and then all the things have to occur in sequence. Okay, and we'll repeat that again as we go through the okay, that went too far. That went all the way back. Way back. Okay. Boiler controls provide the sequence of combustion events during the startup or the shutdown. So this burner controller, boiler management system will sort of old school look like this, and the newer ones can look like this. I prefer this. Turn on the power, follow the checklist for startup. You're going to push one button, something's going to happen on the panel. You can it'll tell you to push the next button. Something's going to happen on the panel. It'll tell you to switch something else on. Something's going to happen on the panel. You'll hit the next button. You'll do everything in sequence, and you'll be part of the startup. Okay. Some systems now you come in, push start, and away you go. Still a good idea to follow the sequence, because if something goes wrong, you're going to want to know what it is. Panels like this will have an indication first out. What is the first thing that happened, so you can find out where you were. But I'm still kind of a pushing the button kind of guy, right? First step is purging. So boiler furnaces must be purged. We're going to force some air through the furnace. Why do you think we're going to do that?
So you'd have a continuous flow of, get rid of all the oxygen out of the tank and have continual flow of gas.
Yeah, in case shutdown didn't go so well. Don't know what happened in the boiler. You just came on shift. You've been off shift for a week or 4 days. First step is get the airflow going. And if any fuel was collected or spilled or passed into the firebox, we want to make sure it's not there anymore. We're going to purge it out. Furnaces must be purged to completely remove combustible gases prior to ignition. We want to have the correct conditions. We don't want to have unknown conditions when we turn on fuel and we turn on ignition, right? So before any lighting of the pilot or the main burners, we're going to purge the furnace. So this control system will have some period of time that it runs a greater amount of airflow to purge the furnace. So forcing the flow of air through a furnace removes the unburned combustible gas. Pre-purge is at the beginning, and at the end, there will be a post-purge cycle. Okay. Operating control will close the switch when boiler pressure or water temperature drops to a desired value. Load or relay of the programming control will close electrical contacts, energizing ignition transformer, fuel oil shutoff valve, motor driving the air or fan blower to purge the furnace. Then we have a spark from ignition, igniting the main burner. Flame detector senses the flame, causes the flame relay to close, and ignition transformer will then shut down. So there's a number of these startup checklists in your book. We're not going to go through all the different variations on that. It's just all these steps are controlled by the system we looked at. So another way to ask you what does purging a furnace means, it means forcing a flow of air through the furnace for a set period of time before the burner is started. So this is actually should say pre-purging, ensuring the removal of combustible gas that may have collected in the interest of preventing furnace explosions. Okay, we talked about low level causing boiler explosions or pressure explosion. This is a different animal. This is every bit as dangerous. It's not necessarily going to blow your boiler out through a wall, but it's going to mean that your boiler is going to have a heck of a lot of maintenance before it can run. And you know what? If you're standing too close, it might take you with it. Purpose of purging, remove combustible gas may have collected. So I talked about some fuel getting into a furnace and combustible gases going through the passes. So furnace may have shut down, unknown conditions, possibly some fuel leaked in. If we have liquid fuel such as oil, there could be a big puddle of oil sitting there for a day, a week, a month, who knows when the last time the boiler was run. And some areas in these boilers and furnaces could be some hot refractory way back here in a far corner. And if we start things up and move things a little bit, these gases could be caused to ignite, and that's when you're going to have that furnace explosion. Okay, so some gas may have collected while the burner was not in operation, and that could cause a furnace explosion. So a purge cleans out those gases, okay? Purge is initiated by the system. All the conditions are met. Air pressure switch is turned on when the fan motor starts, and then we use that air to clean out any possible combustion gases. We'll look at this. Some of you may have seen something like this. You may have seen a version of this. I'm just going to pop back to this. So this kind of a furnace boiler panel will have a bar graph, much like what we're going to look at. These guys won't necessarily have a bar graph that's easily followed. It'll show the steps and what's coming next, but I'm kind of a fan of the other one that shows me this, okay? So if you take a look here, you see 0 on the left, so programming time in seconds. So once everything is set up so that operating controls are all made or closed switches and things are going to start up when we push the start button, turn on the burner switch. 8 seconds later, after the burner blower motor starts, so that starts here. Programming timer is on. airflow switch must be closed. If that switch doesn't close within 8 seconds, the system will shut down. Okay. Airflow switch is closed, system continues to run. Now we're in the purge cycle. So the first 37 seconds here is purge from 0 to 37. And then we start the next operation in the sequence, trial for ignition. Okay. Between 37 and 44, if ignition doesn't occur, the system will shut down, it will stop. Then we run up to 60 seconds and we call it normal firing has begun. And then the programming timer shuts off. This period in here is an hour, a day, a week, or maybe even a year. The programming timer is stopped. The fan is running. It will continue to run unless something shuts the boiler down. The programming timer stopped. Everything is good. When we open the operating control, we walk over and turn the switch off. If the flame goes out, if some other interlock fails, the drive belt on the fan stops, the airflow switch will open. Then the timer starts again and goes into a purge cycle. So the purge cycle on this pre-purge for startup is 37 seconds long. And the post-purge shutdown is 15 seconds, so the time from here to here. Okay, we've got some variations on this, so I'm going to just ask a few questions. What is the length of the cycle? So this timer has a complete length of cycle that is 75 seconds long. 0 from startup. Normal firing period does not add into the time. So after 60 seconds, the timer shuts off. Once we go into shutdown mode, then the timer will start again, and there's an additional 15 seconds. So the length of the cycle for startup and shutdown is 75 seconds. When does normal firing begin? Normal firing begins after 60 seconds. Firing starts here. If burner fails to ignite during ignition trial, a lockout switch will energize, activating an alarm or horn. Timer will revert to 0, and we can't start a new cycle until a certain time has expired, or we have a reset button. When the flame fails during normal operation, we start up the timer and we go through that 15-second cycle. Each time an operating controller or limit switch, such as low water fuel cutoff, opens and shutdowns the boiler, or when the power fails, boiler will start again if the switch closes or power has been restored. In these cases, the lockout switch will not be activated. So depending on what shuts it down, it always goes into the purge, and it normally can start up again if a lockout is actuated. There needs to be a manual reset or restart of the whole cycle. How long is this programmer on? So this is kind of a trick question because it's the same answer as the length of the cycle. Okay, how long is this programmer on? So up until normal firing, it's on for 60 seconds. And it says entire startup and shutdown, so we need to add the 15 seconds here, and the answer is 75. When does normal firing start? This is a repeat, so at 60 seconds. How long is post-purge? This one you're gonna have to answer.
15 seconds.
15 seconds from 60 to 75. Slightly different variation. There's hundreds of variations of these guys. These will be bar graphs that look like this. They might be fancy digital LEDs that flash across a scale and show you different times, but the whole idea is it shows you when the blower motor's on. So from startup or zero, it starts and it goes through the whole cycle, through the normal firing period, and runs to the end of the post-purge. Programming timer is running from zero until, in this case, normal firing starts at 105 seconds ish, 105 seconds. Ignition device is only on between 45 and 70 seconds. Pilot gas valve is only on at the same time, between 45 and 70 seconds. Main gas valve only opens after pilot gas is ignited, so that opens at 55 seconds, stays on. Pilot in this case goes off at 70 seconds. Once the main flame is established, we can run it indefinitely unless there's a shutdown, and then it turns off at this point. And if there's a damper control system, the demand for high fire, the damper will go full open for the pre-purge, and then it will go full open for operation. Okay. So how long is the main gas valve open? You can't really say because you don't know the length of this period here. But when does it open? It opens at about 55 seconds. How long is the pilot gas valve open? It's only open from here, 45, up to here, 70. How long is the timer energized? The timer is only energized between 0 and 105. If the question said energized through the entire startup and shutdown, you'd add the 15-second post-purge. Okay, fairly clear how those work. You're going to see a couple of these on a given Thursday in the future. You'll see one of these and you'll see one of these. Okay, and they're there in the books, they're there in the slideshow with some examples. Page number 10-11. So some chapters have a troubleshooting guide or a kind of a maintenance guide. And these tend to be a sort of a chart looking thing as you're going through the book. And I find that a lot of students don't bother to read them. I highly recommend that you glance through it because there might be a couple of things that you want to remember that you want to highlight. Okay. This is an example from 10-13. So there's one on 10-11. Actually, 10-11 is a time chart for a startup process. So it has the time 0 seconds and it goes to 105 seconds. So this one follows the bar graph on 10-10. It just describes the steps in there. So that's a good one to read. And I actually, I've never read it and didn't highlight it in my book yet, but I'm going to highlight it. Because if you read through that on 10-11, you're going to understand 10-10 so completely that you might be able to teach me a few things about what's on there. So talking about troubleshooting, 10-13, halfway down it says Table 3 Troubleshooting Guide. I don't have anything highlighted on the first page, but on the second page, 1, 2, 3, 4, 5, 6 possible questions in your future. So some of the things that are on that chart actually There are some things on the slideshow. Blower does not start. The solution is reset the safety lockout. So I would highlight blower does not start, middle of the page, and then a little lower on the right, it says reset safety lockout switch. And on the same page, it says no ignition near the bottom, and then it says no spark ignition. Spark, but no steady. So there's some suggested things that might go wrong. Pilot or low fire flame. This is from 1014. Main gas valve might be isolated. Burner stays on low fire. Damper positioning switch incorrect. You're going to find all these things and some possible solutions on 10-14. And this is those same things, okay? Spark but no flame, what's the solution? Shutdown occurs during firing. Something went wrong in those devices where the switches all have to be closed. Damper positioning switch from page 10-14. So good idea to have an idea of what kind of things are on the troubleshooting chart. Exam question guy likes those. He's retired, but he likes those charts. Things that you might pass over, he likes to mess with your brain. Some general troubleshooting, ensure combustible gases removed prior to ignition. Furnace must be purged before light off. Damper motor may not operate if a damper positioning switch. This is from 1014. During startup, you might see a spark, but you get no flame. You could check the manual pilot fuel gas valve on page 1014. So then in here, I have a few more of these. Most of these are repeats that we already went over. So like I said, if you have a real close look at the ones in the book and the descriptions. So 10-8 has one oil-fired boiler controller. And on 10-9, there's a detailed description of the things that are happening. I've skipped reading that forever. Or if I did, I don't remember it. So now I've got it highlighted. So if I've highlighted something in my book, that's an indication that you should use your little, use my crystal ball to refresh your memory. Boiler furnaces are purged to ensure combustible gases are removed. Always purge a furnace before light off. And this is the same thing, just a different version of the jargon. From the troubleshooting guide, spark but no flame, manual valve might be closed. Damper motor may not operate if damper positioning switch is incorrect. Shutdown during normal firing. If you've not closed any valves, I wouldn't check the valves, but I would check the different interlocks. So I have a quick review of chapter 10, and I think it is 1, 2, 3, 4, 5, 6, 10, 11, 12 slides. And then we're done. Purge the boiler. Let me do it this way. Purge the boiler before ignition for what?
To ensure the combustible gases are fully removed.
Correct. Before ignition. Before lighting, purge furnace, remove any combustible gases. Thank you very much. The bar graphics, make sure you understand those. Those are easy marks. You look at a picture, it asks you, tell me the number that's beside this point. Igniter spark is visible, no flame. This is troubleshooting 1014. Mr. Mueller, I'm going to push your mute button. Check the main fuel valve. Shutdown occurs during normal firing. It could be an interlock. Change gears, water tube, fire tube, heating and power, steam boiler, hot water, blow off, blow down. Opening a valve is the same as closing a switch. Start something up. Closing a valve is the same as opening a switch. Open a valve starts the flow, close a valve stops the flow. Concept of upstream and downstream, describing where something is in a diagram is easier if you have a clear understanding of what this means. I thought I had a diagram, but I have a description. I think I've been trying to find a diagram for this. Downstream is the flow of a fluid towards the outlet of a pipe. So we have something coming in and we have something coming out. If we describe a device in this line, whatever that device might be, is downstream on the right or on the left?
On the right.
Downstream is over here because things are going down the stream, okay? Considering conversely. So if you want to describe something that's over here, you're going to call that upstream, okay? This is a repeat. Conditions before starting a steam or hot water boiler by a programming control. So steam pressure or water temperature must be at or below the cut-in of the operating control. Cut-in is where we turn something on, and cut-off is where we turn something off, okay? Cut-in point will be the setting of an on-off controller. You set your boiler to run at 100 PSI. The cut-in might be 95. Boiler will start up. Pressure will go up to 100, which will be the cutout point. Pressure will drop down now that we've turned the fire off to the cut-in point of 95 and then start building back up again. Water in the drum must be above the cut-off point of the low water fuel cutoff. So if there's not enough water in the boiler, it's not going to start up. If the boiler is gas-fired, fuel supply pressure to the burner valves must be above the cutout point of the low gas pressure cutoff. This is a question that's asked procedurally in 5th class, 4th class, 3rd class, 2nd class. Close the main power switch or breaker. Closed means it's on, okay? Main power switch closed means we have power. This tricks lots of people on exam night. Closed is on, open is off. Open is safe. Breaker open is safe. Manual operated valves and fuel lines need to be turned on to pilot and main burner. So if you have started up a burner and you see the flame go out, or you lift a safety, or fan shuts down, first thing you're going to do is close those gas valves. Valves in the system, safety shutoff valves, will shut the gas. Do they always work without sticking 100% and don't pass? Doesn't matter. Manually shut the valve. That will always be your first step. Main gas valve will be big, will be 90 degrees, will be painted orange, will have a big sign on it, main gas shut off. You're going to shut that off if anything goes wrong, right? During program startup, igniter spark is visible, but no flame appears. You might look at the manual valves. You may have just forgot to open them. Shutdown occurs during normal firing. You're going to look at the interlocks. These are things from the troubleshooting on 10/14. Okay, for Thursday, chapters 11, 12, and then after that we have week 4. Chapters 13 to 19 from book 1. This is where we will try to crowd more than these in to give us some time to start this book 1 review. Okay, Thursday,